So for this third question of part A, we're trying to convert the surface 4y squared plus z squared minus x minus 16y minus 4z plus 20 equals 0 to something that we know in standard form. So if we look at the equation carefully, we see that we have two squared components and then nothing squared here on this x. So two squares and one non-square. So we know that we're going to be dealing with some sort of paraboloid, but we don't know which. There's two. So let's start changing this into something we know. We can start by combining our like terms together. We have 4y squared minus 16y plus z squared minus 4z minus x plus 20 equals 0. So this 4y squared has a coefficient out in front, which is 4. So we're going to try pulling that out. And now we have y squared minus 4 times 4 is 16, so minus 4y. And if I do my half and square rule, where we take half of this coefficient and then square it, half of 4 is 2, 2 squared is 4, positive 4. It's always going to be a positive number, so we get plus 4. That takes care of the y's. So now for the z's, we don't have a component here, so we're good. So we can do z squared minus 4z, and if we do the same thing, half and square, half of negative 4 is negative 2 squared is positive 4. And then we still have our negative x plus 20, but I'm going to move that to the other side. So adding x and then subtracting 20. So if you notice, we added this plus 4 here, but really we pulled out a 4. So on this side, we added a positive 16 here, because 4 times 4 is 16 if you distribute. And we didn't distribute anything on the z's, so all we did was add a 4 here. So now to balance the equation, if we add something to one side, we have to do the same exact thing to the other. So we have to do plus 16 and plus 4 on this side. And you notice negative 20 plus 16 plus 4, that all goes away, it adds to equal 0. So now simplifying this, we got 4, and now this whole thing can be simplified to y minus 2 squared. And then we have z squared minus 4z plus 4. That would just be z minus 2 squared. This all equals x. And now this looks something a lot like what we know. We have a plus sign here, so we know that this has to be an elliptic paraboloid. If we go back to the formula of an elliptic paraboloid, we know that in standard form, z over c is equal to x squared over a squared plus y squared over b squared. We have our two squared components here and here. And then we have our non-squared component, which is right here. So we have a plus sign. So we know that this has to be elliptic paraboloid. And this is in standard form. So over 1, all over 1. So we know that this equation is now in standard form of an elliptic paraboloid.